everyone, my name is Sophie. I'm 16 years old. I live in Mexico and I'm in the TKS Global Virtual Program. My main focus right now is on bioengineering, which is this field within biotechnology in which we aim to standardize biology. And the research project that I have been working on has to do with the human gut microbiome, which is this community of bacteria, fungi, algae, and other microorganisms that live in our gut and can communicate with our brains. I know that's crazy. They can induce food cravings that can have an impact on diseases like depression, autism, and yes, also an influence in our sleep. Scientists recently found that there is a positive correlation between the diversity in our gut microbiome and the brain, how well we sleep, and how efficient our sleep is as well. Now I'm going to show you a little bit about how bioengineering looks like on my computer. This is Benchling. It is a cloud-based platform that allows users to engineer biology by designing DNA sequences. And this is a very simple one actually. It is a plasmid. A plasmid is nothing but a DNA sequence that is found in a circular shape. And what we are interested in right here is the GFP gene. GFP stands for green fluorescent protein, and it does what it sounds like. It helps an organism glow in a green color. And what I love about these kind of programs is that they allow you to see letter by letter what your DNA sequence is composed of. So we have actually entered the era in which we can literally just copy and paste DNA. I find that to be pretty mind-blowing, but let's see an example that is a little bit more complex. So this is a plasmid that was created by an iGEM team. iGEM is a synthetic biology competition that I'm actually part of. So these guys created a plasmid that can sense a T metabolite and can react to it by liberating serotonin, which is a hormone that helps us feel happy. So they thought of this as a solution or a possible solution for people with depression. One of my favorite companies in the field is Ginkgo Bioworks, a synthetic biology platform that uses machine learning, robotics, and why not platforms such as Benchling in order to automate some biological processes. Some weeks ago, I applied one of the TKS mindsets in order to meet some experts working at this billion-dollar company. And it was an amazing experience, I could say. Now I'm going to take this a little bit further and I'm going to show you another program that I actually created last week. Not only are we entering the era of copying and pasting DNA, but also the era in which we can program life by using programming languages like Python. So this is a program that I created. It has to do with a branch within synthetic biology called biocomputing. And there are companies in the field like Microsoft which have special teams to just use these kind of programs to standardize biology. And you may be asking yourself, why would I want to, for example, store data into DNA? Well, as you can see right here, we have the equivalence of 2 binary digits equal 1 single letter of DNA. So this already is telling us that DNA is one of the most compact ways to store data. There are actually companies in the field who are already storing that DNA sequence into a plant, into 3D printed objects, and so on. So the program that I created right here basically turns images into a DNA sequence. It first takes the values of color of the images, which are numbers. It turns those numbers into a binary sequence, and that binary sequence, it turns it into a DNA sequence. And then I'm going to paste it here. I'm going to click on enter, and there you go. That's how it looks like. In the end, if I were to give a single piece of advice to anyone around the world of any age who wants to get started in the world of biotech, is just get started. Really, what's stopping you? You could see here that the only thing that I needed was my computer, an internet connection, and yes, of course, a lot of curiosity. So I can also say that if you've already gotten started, then find these intersections between biotechnology and technology, because in the 21st century, we're already making everything more standardizable with computer-aided assigned softwares and platforms such as Benchling and machine learning and many other things. So this will help us make biology more standardizable and more predictable, which I think is where the future is going. And finally, as a conclusion, I can say that TKS has been an amazing experience for me because I have been able to meet some like-minded people around the world. I have been able to collaborate with them, and I have discovered that I'm not the only crazy teenager in the world who wants to get started in biotechnology, which I think is awesome because I've also discovered that networks are very important. And finally, feel free to check out my podcast at 2045 Podcast on Twitter, Instagram, Spotify, Apple Podcast, or anywhere you get your podcasts. There I talk about exponential technologies, the mindsets that you need to succeed, and many other things as well. So feel free to check that out. And that's it for me. That's how you engineer biology.